All right, so today we are starting in the math world of things. So essentially what we're going to do over the next couple weeks, probably end up being about 2.5 weeks, we're going to start on Unit 0. Unit 0 is really just a review of that basic algebra, Algebra 1, just to kind of get you back into the groove of doing some algebra stuff. And it allows for other things for me as well to kind of check out to make sure you're in the right class. We're going to go fast over the next couple days. There's going to be a lot of stuff that I expect you to know how to do already. I'll show you quick examples today, and this is stuff that I expect you to know how to do. We'll do mostly 2 lessons in one day, not every day. Like tomorrow is just one day, but it's a longer lesson tomorrow. Today we're going to go through day 1 and 2. But again, kind of back with, let's me figure out if this is where you need to be and figure out quite quickly if you need to be in just regular Algebra 2. And then we can just move you right to Algebra 2 instead. So that's not going to be the case for like all of you, but just in case it does happen, then we got it taken care of. So we're going to take care of 2 things today. We're going to talk about simplifying expressions with distributing and like terms. So obviously we want to be able to do those things. And the other thing then we're going to do is we're going to work on FOIL. That's kind of the second lesson for the day. Again, both things that you should already be able to do. So just going to jump right into it. Not with that one. Where did it go? How did I get so far ahead? We're going to jump right into that one. Go ahead and simplify that, and I'll get your phones while you're simplifying that. Thank you.
I have a question.
I have an answer.
When does lunch end?
44, you need to be in this room.
Okay. No, I started making my way back at 39.
This is not bad.
It is. That's the hope there.
Oh, so it ends at 39. Yeah.
And I didn't know I was still eating at 39.
Yeah, I was late yesterday. Hopefully, right?
That's actually the strap.
That's actually so bad.
I know. Actually, so no.
I wish we had lunch.
Services, guys.
Yeah. And stupid Spanish. Oh, wait. I live in you live in Minnesota? No, I live in
No, not this.
So should be pretty straightforward for all of you. I do these a little bit different than some teachers. What I like to do, just to keep my brain kind of focused in there with what I need to do, I do go ahead and underline. So I'm going to give that one 2. I'm going to give this one 1. I'm going to give this one 1, probably in a different color, or maybe not in this case, even give this one anything because of what it looks like. I have the option of doing a different color, but I'm going to underline that one with 2 as well. Any idea why I would underline those with 2? Because it's x squared. It just, to me, in my brain, it's x squared. Squared means 2 lines, cubed means 3 lines. If there's nothing there, like with the 2x, just 1 line. If it's just a constant, no lines at all. That does a couple things. It allows you to kind of organize it in your brain a little bit better, and you can see easily, I need to combine the ones that have 2 in there. They have to have the same variable, and they have to have the same exponent in order to combine them by adding or subtracting. And then we're just going to add the numbers together. It's the first thing it does. Second thing it does is it shows me what order to go in. You're always going to go from the most number of lines down to the fewest number of lines. And keep it in terms of, if we start with x squared, then you go to x, then you go to your y's, if the variable changes. So 3 plus 4 is 7. So this is 7x squared. The base, which is your variable, the base remains the same. The exponent remains the same. You just add the numbers or the constants. We don't have anything to connect with the 2x, so we just bring the 2x along for the ride. We bring the y, negative 3y along for the ride. There's your solution, and you're done. You've combined the like terms. Questions with that type of problem? Do I need to do any more of those?
No.
Right, and I wouldn't expect that with you guys. Just quick, don't write this down. Just a quick reminder, don't do this one. Just remember when you distribute, to distribute means that you take that outside number times each of those terms that's inside of. So in this case, we would have 6x plus 10. You're done. It's simplified. We're not solving. There's no equal sign. That's the distributive property. Again, you've seen the distributive property a lot. Just wanted to show it to you real quick because in the end, I don't need you to be able to do that type of problem. I need you to be able to do that type of problem. Go. See how you do with that one. Again, as I'm going over this today and over the next couple of weeks, please understand that this is not typically how this goes. This is material that I expect you to know already. If you don't, then you need to just kind of schedule time with me to make sure that we get you caught up with these things over the next couple of weeks. Generally speaking, I'll take my time and I'll slow down and it won't be this fast and I'll do more explanations. This is stuff you should know. Give you about another minute. If I do 9p times p, what is the answer?
9p squared.
9p squared. So you distribute that first one, make sure you have 9p squared.
You're very good at whistling, Mr. Anderson.
All right, here we go. So we distribute 9p times p is 9p squared. 9 times negative 8, negative 72p plus 4p times 1 is 4p minus 20p squared. All of my variables are p's, so this is 2, 1, 1, 2. I look for my 2's. 9p squared minus 20p squared. 9 minus 20 is negative 11. So we've got negative 11p squared. Base remains the same as well as the exponent. Negative 72 plus 4 is negative 68p. Combining like term with the distributive property, are we okay? Do I need to sit here and do 27 more examples? Because I have plenty of them that I can do. But I don't really want to do them if you guys are good to go. Okay, then let's move on. Next one then, you don't need to really write this down, but it's simplifying expressions involving multiplying binomials. Okay, so now we're going to take this and say, all right, now we got to multiply two binomials together. Just remember by definition, what's a binomial? A binomial is a polynomial, which is just a bunch of terms added together. When there's more than one of them. There's two of them, there's three of them, there's four of them, whatever. Binomial has two. Polynomials are just the sum or difference of a bunch of monomials. Okay, so we think about multiplying binomials. We're going to look at multiplying something like 3m minus 2 times 5m minus 5. This is the distributive property. Okay, so this is done through distribution. What distribution means, if you have a grouping of things, it means that you need to take everything in the first grouping of things times everything in the other grouping of things. Whether it's 1 when it's just a distributive property, or if it's a binomial times a binomial, or a trinomial times a trinomial, or whatever. Every single term from that first grouping has to be multiplied by everything else. So I have to take 3m times 5m. 3m times 5m is 15m squared. I have to take 3m times negative 5, which is negative 15m. So now I've taken the first times the first, and I've taken the outside times the outside. I've taken every term from the first one times every term of the second one. Now I have to do the same thing for the second term. I have to take negative 2 times negative 5m, which is negative 10m. And I have to take negative 2 times negative 5, which is positive 10. Now I've taken every first term from the first, taken every term from the first times every term from the second. This gets 2, 1, 1, none. So combine like terms, just like we just did. Minus 25m plus 10. That's your simplified form. It's the distributive property. What else have you heard this as? FOIL. First, outside, inside, last. But FOIL, that acronym only works if you have a binomial times a binomial. That's why I don't like to use that word very often. Okay? It only works when you have 2 times 2. If you remember the concept, if I have 3 terms times 3 terms, I just have to take the first term times all of them. I have to take the second term times all of them. I have to take the third term times all of them. Combine like terms. We'll do those later. That's not going to be today. Okay, multiplying binomials, give you one to try on your own, and we'll come back and talk about one that I just passed. Okay, so let's combine the two things. So use the distributive property with 2 binomials, and then combine like terms to simplify that one. You can listen to me whistle. Warm outside again. Tired of being warm. Practices are way too hot.
I was cold yesterday. What? Yeah, which is why I wore a sweatshirt today. But now I'm like warm, so. Yeah.
Practice was supposed to begin yesterday.
Practice was easy yesterday.
Practice was nice there, so we just did sprints. We got to watch soccer practices. Soccer practice? You guys have games tomorrow?
Today.
Oh, it's today? Oh, today's Thursday.
Tomorrow.
You're here too tonight?
Yeah.
Who do you have?
Cassie.
They're generally pretty good, aren't they?
Yeah. What are we doing today for practice?
Miles.
Yeah.
All right, x times 2x. 2x squared. X times 3 plus 3x. 5 times 2x, negative 10x. Negative 5 times 3 is negative 15. Minus 5x squared. Plus 7. Everything look right so far?
Yes.
2 lines, 1, 1, none, 2, and none. So I look for all of my 2's. 2 lines there, 2 lines there. Negative 5 plus 2 is 3. So 3x squared. Negative 7x. Ooh, that's bad. Come back. Minus 7x. Minus what? Yep. Minus 7x.
Yeah. Negative 3, right? Minus 6.
Wait.
Negative 5 squared. Negative 5 and negative 3.
That says negative right there. I was just making sure you're paying attention. So is it right so far? I start talking about other things and thinking about other things in my brain, just going so fast sometimes, which you guys probably do. Negative 8, look right? In all honesty, if you see things that look wrong, tell me. It might be wrong if a vast majority of you, if you look at the person beside you and you both have something different than I have, ask somebody else around you, because that happens all the time. Okay? My brain just starts going in a different direction and I miss a negative symbol or I add wrong. It happens. It happens to all of us. It's just the way it is. Do I need to do any more of these examples? We're okay with simplifying and using the distributive property and doing all of this, right?
Yeah.
All right.